Have you ever built an app that works absolutely perfectly on your machine, but then just breaks the second you try to deploy it? Oh yeah, we've all been there. Today, we're going to tackle that exact problem. We're going on the full journey, from your local code all the way to the cloud.
So, you've done it. The code is written, it's clean, it's flawless, at least on your laptop. But, that's really just the beginning, isn't it? The real question, the one that matters, is how do you get this thing out into the world so it actually works for everyone, everywhere, every single time?
All right, here's our game plan. First, we're going to set up a really simple two-app system. Then, we're going to smash right into our first major roadblock, what I call the localhost fallacy, and we'll see how to solve it with Docker Compose. After we navigate some of those little real-world bugs that always pop up, we'll finally level up to a real production setup with Kubernetes and really get our heads around the crucial difference between pods and deployments.
So our whole scenario today is built around two pretty simple microservices. Just imagine one app is for creating your to-do list tasks and another one is for tracking your progress. They're simple on their own, but here's the kicker. They absolutely have to work together perfectly.
Okay, so on one hand, we've got our to-do app. Its job is to create and manage tasks. On the other hand, we have a progress app that just logs when a new task gets made. And here's the catch. The whole reason we're doing this, the to-do app has to communicate with the progress app every single time. This simple dependency is what's going to put our entire deployment strategy to the test.
So, everything's running just fine on your machine. Time to containerize them with Docker, right? Easy enough? Well, this is the exact moment where a super simple setup can suddenly turn into a massive headache.
See, on your local machine, things are a breeze. The To-Do app just calls the Progress app using localhost 8001. It just works. Why? Because they're both on the exact same network, your computer. So naturally, you put each app into its own Docker container. The To-Do container logically tries to make that same call to localhost 8001, thinking it's going to reach the Progress container. Makes sense, right? But nope, it fails. The call just goes nowhere. So what gives? It's because inside a container, localhost doesn't mean what you think it means. It's not your computer anymore.
And here is the absolute key to understanding this whole thing. Inside a container, localhost refers only to the container itself. That's it. Think of each container as its own little isolated island with its own private network. By default, it's completely blind to the outside world, and, more importantly, to any other containers running right next to it.
So, how in the world do we fix this? Well, we need to build a bridge. We need to create a shared network that lets our little isolated containers finally see each other and start talking.
And the perfect tool for this job is Docker Compose. It lets you define your entire multi-container application in a single file. And here's the magic part. When it launches your containers, it automatically creates that shared network for them. It's a game changer.
And check this out. This is the elegant solution. As you can see right here in the code, instead of trying to call localhost, our To-Do app is now configured to call the other container by its service name, in this case, Progress app. Docker Compose acts like a tiny little DNS server, making sure that name points to the right container's IP address. And just like that, communication is restored.
Okay, but even with the networking problem solved, let's be real, deployment is rarely that simple. Now you're about to enter what I call the gauntlet of small, frustrating, and absolutely critical details.
You're gonna hit these real-world errors. It's inevitable. A single typo in an image name, a subtle mismatch between Python versions, an invalid command you didn't see. These aren't huge philosophical problems. They're tiny little mistakes that demand absolute, painstaking precision.
It really all boils down to a core belief in DevOps. In deployment, every single line matters. A small mismatch can break the entire platform. Around here, attention to detail isn't just a good habit, it's everything. It's the whole ballgame.
Okay, so our app is working perfectly locally with Docker Compose. Awesome. But now it's time for the big leagues, a real production environment. And that means we need to learn to speak Kubernetes.
You see, in Kubernetes, you don't just run a container. That's not how it thinks. You declare the state you want to exist. And you do this using a YAML file called a manifest. It's basically a blueprint you hand to Kubernetes saying, hey, here's my application, here's the container image it uses, and this is exactly how I want you to run it. And the great news is, you don't have to write these manifests from scratch. These powerful command line tools can generate all the boilerplate for you. This kubectl command is basically saying, hey, plan to run my to-do app image, but don't actually do it yet. That's the --dry run part. Instead, just spit out the YAML definition for me with -o YAML. It's a massive time saver.
All right, we're at the final and probably the most critical concept for any production system. That manifest we just generated, it creates a Kubernetes object called a pod. But what exactly is a pod, and is that really what we want?
So a pod is the smallest thing you can deploy in Kubernetes, and it runs our container. So isn't that enough? I mean, we have our container running inside a pod, job done, right? Well, not quite.
A naked pod, one you just create directly, is incredibly fragile. As you can see over on the left, if it fails, it's just gone. Proof. A deployment, on the other hand, is like a manager. Its entire job is to watch over your pods. If one fails, the deployment controller instantly spins up a replacement. No questions asked.
So, using deployments gives us basically 3 superpowers. First, self-healing. It automatically replaces any pod that fails. Second, it maintains our desired state. If we say we want 3 copies of our app running, the deployment will always make sure there are 3, no matter what. And finally, it handles scalability, effortlessly managing the process of scaling up or down.
Look, if there's one single, most important rule to take away from all this, it's this. You never, ever deploy a naked pod in production. You always wrap it in a deployment. That is the fundamental difference between a fragile app that will fall over and one that is resilient, available, and can actually heal itself.
And that brings us to the end of our journey today. We went from a simple localhost call that didn't work all the way to a self-healing deployment in the cloud. It really just leaves us with one final question to consider for any application you build. Sure, it might be running, but is it resilient?